So here is your GeoLab table. It has the 3 seismic stations, and it already gives you the P and S separation time for Boulder, Colorado, and Knoxville, Tennessee. So you need to find out the P and S separation time for Berkeley, California, using this seismogram right here down below. So step 1, the seismogram in figure 1 shows the arrival time of the P wave, see it right here, at 10 hours, 50 minutes, and 32 seconds. Go ahead and underline that time because you're going to need that later to determine when the earthquake occurred. So make sure you pay attention to that one right there. And then you're going to estimate the arrival time of the first S wave to the nearest 10th of a minute. So you'll go over here to the S wave, use your ruler, make a line straight down, and you will need to determine what time that is right there. Okay, and then you need to figure out the distance, the separation of time between the P and the S wave. So if you had, you know, a ruler straight down here, a line straight down there. So you need to look at these times in seconds right here and figure out what, you know, how many seconds that is. What I do is make a line here for 5:40, make a line here for 6:30, and then you can figure out halfway. So the difference between here and here is 90. So if I took my ruler, and I like to be as detailed and exact as possible, so I'm going to use my ruler. I'm going to count these millimeter lines. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So halfway would be 6. So I'll make a mark halfway. So if the total is 90, that halfway mark, oops, I think I wrote it a little bit wrong. It's a little difficult to do it when I'm looking through the camera. So that's more at like 7. So let's do it right at 6. Okay, so that bigger one is halfway. So that's 45. So 45 plus 540 is 585. So that's 585. So that's about halfway. So you can figure out exactly where that is based on, you know, counting these. And then you need to figure out where this is. And I would write it right here and right here. Okay, so then you'll subtract the S wave time from the initial P wave time. So if, you know, this was 560 and this is 330, those are not the exact answers. I don't want to give you the answers. I just want to show you how to do this. Then you'll subtract, you know, 560 from 330 and get a certain amount of seconds. And you need to convert that to minutes and write your answer right here. All right. So you'll enter this value in the data table for Berkeley seismic station. And then the P and S separation observed on 2 other seismograms, which are not shown, are also listed right there. Use the travel time curves in figure 2 to determine the distance at which the P and S curves are separated by the time intervals listed in the table. Enter these distances in the table under the epicenter distance. So let's do one of these ones so I can show you how to do it. So we're going to do the 3.5 minute separation. So if we look here at figure 2, what we're going to do is over here on the left, well, there's 2 ways really to do this. This is the travel time in minutes. So if Boulder, Colorado had a P and S separation of 3.5 minutes, we're going to need to figure out when this distance between these 2 was equal to 3.5 minutes. So here's how I like to do it. I'm going to take a little piece of paper and I'm going to line it up right here. All right, so I'm going to say the bottom, oops, let's do it this way so I can see the numbers. So the bottom is 0, and then we're going to move up to 3.5. Actually, I'm going to move it over a little bit more so I can see the halfway mark since it's 3.5. So there's 4, there's 3, so 3.5 is right there. Okay, so now I know this distance is 3.5 minutes from this edge to that point. So now I'm just going to use this to move along my travel time curves, the P and S wave curves, to find where these numbers fit, or this space is exact. So this one right here is pretty close, but see how the line's a little bit below that top part? So you want to be as exact as possible, so I'm going to move it up a little bit more. And look, that looks a little bit more accurate. So wherever this is, I'm going to follow this line straight down and make a mark. So this is the distance that these two waves, or these waves had to travel to be this far apart. That's the distance of the, how far apart they were. So you're going to figure out the values here. So this is 2,000, this is 3,000 kilometers. It looks to be right in the middle. So, and then it would be 2,500 kilometers. So this was the one for Boulder, Colorado. So let me show you that again one more time. And I always, guys, like to double check it just to make sure I'm doing this correctly, because if your circles are a little bit off, then you might get the wrong answer. They might not match up. So I'm going to do this again just to make sure. And actually, let me do it on a different side. So I'm looking for 3.5. So there's 0. There's 3.5. I'm going to move along until these are exactly apart. So this time I got it a little bit smaller. This time I got it right there. Last time it was here. So that's 2,250. So what do? I got two different numbers. Well, I'm going to do it again. So I would do it again just to make sure, measure your distances. And you can also use a ruler to measure if you want. So you can measure up to 3.5, count the millimeters, and then find that same distance right here. So that number is going to be put in the epicenter distance right there. That tells you that those waves had to travel that far to get that distance apart. So I would put my 2250 or 2500 in this line right here. All right, so you're going to repeat that for Berkeley and Knoxville, Tennessee until this is completely filled out. And then we're going to move on to number 4. Now this one, you can just use this graph right here if you want. It works just fine. Or you can trace this onto a tracing paper so you have more room. That's fine too. But what we will do is determine the epicentral distances on your tracing or on this map using a scale of 1 centimeter, which is equal to 500 kilometers. So let's say I'm going to do the 2250. If every 500 kilometers equals 1 centimeter, I need to figure out how many centimeters that is going to equal on my map here. All right, so if I have 2,250, then 1,000 is 2 centimeters, right? So every 500 is a centimeter. So we got 500, which is 1, and you can even do a tally. 1,000, which is 2. 1,500 is 3. 2,000, that's 4 centimeters. And then I have 250, which is half of 500. So then I have a half. So this would be 4.5 centimeters. So that tells me that from Boulder, Colorado, right here, the epicenter of the earthquake on this map is 4.5 centimeters away. All right, but it can be in any direction. We don't know the direction. So what we have to do is use the compass to draw circles around each station on the map with the radius of each circle equal to the map distance in centimeters for that station. So we take our ruler and we take our compass. And I'm going to set my compass, the point on 0, and then the pencil will be on the distance that we just figured out, which is 4.5 centimeters. Now on yours, I think you can tighten it down. Mine's a little cheap one and I can't tighten it down, so it's kind of hard to draw a circle. But then I'm going to put the point on the seismic station. The pencil will be the 4.5 centimeters away. And then you draw your circle. Like I said, this compass is not very good. Your guys's are better. But I'm going to draw a circle the best I can. Oh, it's like getting off a little bit. All the way around. Hopefully it meets up. Pretty close. Good. Okay, so there's my first circle. Now I'm going to continue that process with the other stations. Berkeley, I'm going to figure out the map distance, the centimeters, and draw a circle around it. And then I'm going to go to Knoxville and do the same thing and draw a circle. There will be a location on here where there's 3 circles. So I'm just going to draw an example here. Let's say that's one station, this is the second station, and this is the third station. Okay, now there will be one place where they meet. Now we're doing this with not the best equipment. So in this case, this is the location right here that it meets. Even though they don't all touch, that's the closest spot on our map for the epicenter. So you'll look for the closest city and identify it that way. The next thing you need to do, well, you have to mark the point of intersection or really close intersection. You can see this one that's not even close. There's only 2 there. There's only 2 there. There's only 2 there. This is where they all 3 meet. So mark that on your map and then determine the time of occurrence of this earthquake by reading the P wave travel time from figure 2 for the epicentral distance for Berkeley. So whatever we figured out for Berkeley on here, let's say we figured it was 3,000 kilometers, we'll go up to the P wave time, and it took 6 minutes for that P wave to travel that far. So if it traveled 3,000 kilometers from Berkeley, it took 6 minutes. So that means the epicenter it took 6 minutes before it reached here. So then we're going to subtract this from the initial P wave arrival time at Berkeley, which was 10 hours and 50.5 minutes. So that it tells you when it arrived. So you just have to use this time. So if it was 6 minutes, you would subtract 6 minutes from this, and then you would know the earthquake occurred at 10 hours and 44.5, but it tells you to give it in seconds, so 0.5 minutes is 30 seconds. So you need to give it in the hours, minutes, and seconds that it actually happened, and then it took 6 minutes to get to this point, or whatever you figured it was over here. All right, so then you will answer these questions, and I'm going to give you a little bit of information about these. So you need to write where it's located, what's the closest city, in which major seismic belt did this earthquake occur. Now in your book, there's a little section on seismic belts. It doesn't tell you the exact answer, but I think once you figure out, you can look at this, once you figure out where it is, you can look at what the seismic belt is there. And it only gives you 2 options. Okay, so I think you can figure that one out. And then you use figure 3 to determine which plates form